with a keynote from Addison Snell, who is the CEO at Intersect 360. And his company is very focused on market research in the high-performance computing area. So we've asked him to put together some good data for us to give us an idea of where is OFED penetrating today and where can it penetrate tomorrow. So I'm excited to see some of this, and this is probably one of the first times that OFA as a body has really asked for this type of data. So I'm excited that we have it, and we'll be able to use it to plan forward, and I think it'll help us in our panel discussion later. So without further ado, I'd like to introduce Addison. You should be able to use this.
Great. Thank you. I'm Addison Snell. I'm with Intersect 360 Research. We are, as Tom was saying, a market advisory research and consulting firm specific to high-performance computing. We're a small company, but exclusively focused on the HPC space. We have 4 analysts dedicated to it. Myself, my partner, Chris Willard, who's our Chief Research Officer. He's presented at this conference in recent years, and I'm stepping in for him this year. I myself was last year at this conference in Sonoma, I think 3 or 4 years ago. Also, Laura Segerval and most recently Sue Korn joined us. I'll come back around to some of her work in financial services specifically later in this presentation. We have very inclusive views from a research perspective, both in terms of the technologies that we cover and the usage models that comprise high-performance computing. From a technology perspective, we're dedicated to the notion that the high-performance computing market is more than just servers. There's a lot of other things that comprise high-performance computing, and things like networking and middleware and optimization, even services, fall into that category. From a usage standpoint, foundational to our research is the notion that there are both high-performance technical computing applications in engineering and science and high-performance business computing applications in things like complex event processing or business process optimization, and we cover both of those. Most of our research comes through syndicated reports from annual surveys that we largely do based on our research partnership with HPC Wire, although we do use other panels as appropriate. We do technology trend analysis, we do market sizing and forecast, we do custom projects for our clients. And some of you might actually recognize me from the fact that I have a weekly podcast that I do together with Michael Feldman, who's the editor of HPC Wire. We have an awful lot of fun with that, especially last week did we have a lot of fun with that. And any of you who know what I'm talking about, super. If you don't, I highly recommend last Friday's podcast. And that's all I'll say about that. As for the agenda today, I was asked to look at OFED in HPC and beyond, so we'll start with the HPC part, and then we'll move into some of the other opportunity areas, including some of the emerging technology areas like GPU computing or cloud computing and what effect they might have on OFED adoption. In terms of OFED specifically, you know, it fits into an interesting niche in terms of the overall high-performance computing or general optimization stack. And although it works with multiple fabrics, of course, it's typically associated with InfiniBand, I think partly because of its heritage with Open Fabrics Alliance. We did have a few Ethernet-focused presenters yesterday, and some of that was the cause for some of the debate in some of the Q&A. Now, it is probably in use in, or at least part of the stack, in most InfiniBand or RDMA types of installations. But what we have found in our research right off the bat in terms of how many people are using OFED or what its current penetration is, that we do survey directly what people's middleware usages are. And we ask very specifically what kinds of what kind of tools, what kind of performance optimization you have. Out of over 1,400 named middleware instances, we found 2 mentions of OFED across 263 sites. So that's under 1% of sites mentioning that they have OFED. That's clearly not right. What that means is that people might be using it, but they're unaware that they're using it. And this is actually a point that I'll come back to throughout the presentation, which is as you talk about wanting to grow the penetration of OFED or move it into other markets, this question of conscious versus unconscious usage is going to be an important one. Is it that you want more people to use it, or is it that you want more people to be aware that they're using it? And that's actually two different things. You can have the former without the latter, and there's a question as to whether that would constitute a victory. Nevertheless, for the time being, we'll use InfiniBand penetration as a proxy for OFED usage based on our opinion that most InfiniBand users in HPC have OFED in their stack and are probably using at least part of it. And for those that aren't, there are probably some small proportion of Ethernet users who have it as well. Some of the things I've heard this week, some of them are pro-OFED, things like if, as an application developer, if I don't have to go out to the kernel, I won't. But also some other points that really underscore that, the point I was just making about unconscious usage. The end user doesn't see it. We use every bit of it, but we don't look at it that way. Overall, it's supposed to provide a benefit of efficiency in data centers, but we also found some of the limitations around that. It's hard for a data center user to view it as standard. It might be hard to install. It's not necessarily seen as an essential part of my enterprise computing stack. In terms of the forecast, the market size right now, and you'll see an asterisk on there, this isn't yet published. We're still in the final planning stages on it, although I think the high-performance technical computing portion is fairly well nailed down. I don't expect it to move much at this point between now and publication. Total market for high-performance technical computing in 2010 is $17.4 billion. That's a large growth from a recessionary 2009. So we did expect to see a big growth rate. The only debate we were having this time last year when we were forecasting it was how much of the growth would come into Q2 of 2010 versus pushing out to Q1 of 2011. We did see that pick up really starting toward the end of 2010. We had a pretty good Q3 and a very good Q4. That drove the growth. We should still see a big 2011, again driven mostly in the first half of the year as we continue to catch up. That said, I will say that the growth we're expecting in 2011 is going to be driven primarily by industry. We expect that in North America specifically, government spending and then to a sort of a shrapnel effect to education spending might be hampered by the current budgetary climate in the U.S. administration. Servers are about 38% of that total $17.4 billion. That $17.4 billion is all product and services spending for HPC. It doesn't still include other things you could throw into total available market calculations that are internally spent items on things like staffing and facilities costs, which we don't consider to be external spending. Next largest categories are software and storage. And let's see, I've made those other points, so I can move on. In terms of interconnect usage in HPC specifically, now this is all survey-driven data, but we can retrofit it into total market models. What we found is that Ethernet is still a very solid choice across system interconnects, storage interconnects, and LAN interconnects. We break out all three of those things in terms of the different areas where an interconnect might be used. System interconnect, this is your node-to-node interconnect within a cluster. Storage interconnect, of course, is the I/O out to disk, and then you have a LAN, a compute network. There is still a role, of course, of fiber channel, mirror net, various proprietaries. We could break this out by speed. I do not intend to read this whole chart. More instructive than dissecting this entire chart is to look at Ethernet usage versus InfiniBand usage and how they differ. The red bar on this chart is the InfiniBand portion of system interconnects. And if we rolled this pre-2007 back in time, what you would see is, it'd actually be probably more instructive to put the green in the middle. The green is all the proprietaries. But what you would see out here is a larger green bar and shrinking red bars. And what happens is the blue Ethernet portion, although it pulsates a little bit up and down depending on when there's a new version of Ethernet available, it's largely oscillated within the same range. And InfiniBand's growth, which is quite evident here, has come largely at the expense of the proprietary interconnects. This is absolutely fresh survey data. We just ran this survey. It includes systems from the first quarter of 2011. That's not a full year, but nevertheless, there's a few systems in there. So, this growth from here to here, don't take that as too much of a thing yet. This isn't a full year of data. But going forward, we would expect to see this ratio stay about the same, where if you're now the other thing I should mention is this is the x86 based cluster blade portion of the market. If we included larger SMPs, vectors, you'd see more of the proprietaries and things getting in there. But we expect to see those ratios stay about the same, where out of the cluster market, InfiniBand is half, maybe a little more than half, and that Ethernet probably isn't going away. It would take a big leap to say that we expect InfiniBand to take substantially more than 60% share of the cluster market when Ethernet has been so stable for so long a time. Furthermore, there are particular market segments that seem to be very strongly aligned to Ethernet, including academia, bio and life sciences, and oddly enough, finance. For as much as they're latency sensitive, they also seem to be Ethernet bigots. The banking industry is definitely standardized on Ethernet and probably will continue to be so. Then from beyond that, we can look at how InfiniBand usage and Ethernet usage differ according to how they're used within a site. I was looking exclusively at the system interconnects on the previous chart, that histogram. In this case, what we're looking at is out of all of the sites who mention they have InfiniBand, someplace within their HPC installation, how does the deployment look? And what you can see very quickly from this Venn diagram is that 96% of the InfiniBand usage is at least with people who have it as a system interconnect. It's fairly rare to see it as a storage interconnect or as a LAN without it also being a system interconnect. That said, compared to previous years, we do see more of it creeping into these boundary conditions where it's not just exclusively in the system. You now have 30–40% of the market is using it in multiple locales, the system and a storage or LAN or both. 14% of the InfiniBand users have it as a point of convergence for all three, and we do see those shares has been growing. If you compare this to Ethernet, here the numbers shift substantially. Where the InfiniBand numbers were dominant in that system circle, here the Ethernet numbers are dominant in the LAN circle. 83% of Ethernet usage falls into the LAN circle, although you do see 14% as a system interconnect and nowhere else. The other important point here is that over a third of the respondents for Ethernet are right in the middle. They've got, in essence, a converged fabric on Ethernet. Everything is Ethernet. The LAN is Ethernet, the storage is Ethernet, the system is Ethernet. The overall conclusion is, in order to grow OFED's penetration, you're going to have to cope with the notion that you're not going to deal primarily with all InfiniBand environments. This has to be an inclusive story together with Ethernet, together with fiber channel, and to the extent that you're going to run into converged fabrics, you're going to see them more often on Ethernet than you are on InfiniBand. So this is a fundamental point with regards to expanding OFED's penetration, is you're going to need to get over that hurdle of having it be primarily thought of as an InfiniBand technology. I mentioned we were looking at high-performance technical computing and high-performance business computing because this does represent another potential area for growth. High-performance technical computing we define as being science and engineering types of applications. The top verticals within that are academia, which often gets discounted. Oh, there's those academics, right? And they don't spend very much. Nevertheless, academia as a whole is the top vertical market. The government sector also comprises quite a bit. We break it out into government labs and government defense, but still those two separate ones, each individually, are bigger than any of the individual commercial segments. That said, commercial as a whole represents about half of the total high-performance technical computing market. The largest sectors there are manufacturing, bio, and energy. Then there's a cast of thousands after that. High-performance business computing. Those of you who've seen me present over the last couple of years might have heard me refer to this as edge high-performance computing. We're formalizing this methodology with more research going forward this year and reterming it high-performance business computing. It is comprised of applications that fall into particular categories. Complex event processing is anytime you have multiple real-time data feeds, sensors, what have you, and you're looking for what could loosely be termed as events in the data. High-frequency trading is the best example of this, although by no means the only one. Business optimization covers a wide range of high-end business intelligence, data mining types of applications, logistics applications. Walmart is a poster child here. Virtual environments is kind of our catch-all for, well, not catch-all, it's the category that's largely dominated by online games. There are fairly large real-time I/O installations behind things like World of Warcraft that support millions of simultaneous users. And ultra-scale business computing, this is where I should have used the term catch-all. This is our sweep category for things that don't meet any other definition of HPC that we have, but nevertheless are being done at a level of scale that implies supercomputing. So my favorite illustrative example here is online retail we do not consider to be HPC. Amazon has a supercomputer that we need to count somewhere. It goes in here. Top verticals for that then, financial services, online games, retail, internet, digital content creation and distribution we used to have in technical computing, this entertainment category. We're moving it over to business computing. Go ahead, Josh. I can take a question now.
Sorry, where do you put big data analytics on the business side and data-intensive computing on the HPC side?
The question was, where do we put data analytics, big data computing? I had to look at the specific examples, but my tendency is going to say they're mostly in high-performance business computing applications. We have analytics applications in there. In fact, I have a finance slide here that I might as well jump ahead to now. We just published a taxonomy of this. I mentioned we hired Sue Korn. The whole point of us hiring Sue Korn is that she has 20 years of experience in financial services and is completely representative of the notion that these end users largely don't think of themselves as high-performance computing users, whether we call it high-performance computing or not. She has experience in all of these different application areas that we mentioned, but we find that the applications in finance fall into 4 categories: trading, risk management, pricing and valuation, and business and economic analytics. Furthermore, that if you're going to categorize the users in this space, it's a lot more difficult than just saying bank. Most of the clients that you would find in this industry are what you would call a multi-line. They have checking accounts, they have credit cards, they do insurance, they do multiple lines of business that you need to consider. And then furthermore, finance in this case doesn't exclusively have to be a commercial type of user. There are financial applications in some government types of things, like, say, Fannie Mae or the Fed, right? These are financial services applications that we need to count here, even though they're government, not commercial. Backing up one slide, Beyond high performance technical computing, you can consider InfiniBand and OFED in high performance business computing and the data center. Now, if you go here, Ethernet usage starts becoming much more common. We're looking at roughly 50-50, maybe 60-40 split in high performance technical computing. But when you go into high performance business computing and the data center, although the data center is not an area we surveyed directly, it's certainly our opinion that Ethernet is much more common there. There's a lot more focus on standards, optimization, and you can't just go in and say, well, we're going to give you more performance on your Monte Carlo, and here's the benchmark. You're going to need to meet the IT hurdles that go along with competing in the data center. One way to encapsulate this that my partner Chris has coined and brings, and I quote him on it often, is that in HPC the watchword is once you've solved the problem, it's no longer interesting. In other words, you don't need to design the same bridge twice or discover the same protein twice. Once it's discovered, it's discovered. You've solved the problem, you move on. Whereas in enterprise computing, the watchword tends to be once you've solved the problem, for God's sakes, please don't touch it ever again. We needed to continue running the exact same thing over and over again, forever and ever. Amen. Thank you very much. Good night, everybody. Right? That makes it a lot more difficult to introduce new technologies, regardless of how good they are. Morgan Stanley's over here nodding. He knows what I'm talking about. There's a lot more conservatism toward new technologies. And the discussion yesterday about, we tried to install it and we thought it was going to work and it breaks is the nightmare that's going to scare away the data center user for another decade or two. Cloud computing is another area of discussion. We hear a lot of talk about cloud. And when we surveyed it, we found a lot of people are looking at cloud. However, as with grid, and there are an awful lot of similarities between cloud and grid, both in terms of adoption and discussion and technology, but regardless of that, as with grid, we find that most of the early adoption is skewed toward private and hybrid types of installations. Now, when we discuss private versus public in terms of cloud, definitional things because we're talking about cloud. First of all, there's a few different predominant definitions of cloud, and I'm not going to say that one or the other is correct. I'm going to start saying here's what we're talking about. One definition of cloud that we see is cloud as an access model. I'm running my application on someone else's resource in some way. It's a utility computing type of definition. With regards to high performance computing, which is where we are, that's the most pertinent, relevant definition and is the definition we were using for this survey. Another definition of cloud that we sometimes see is the notion of cloud as an architecture. This is my IT infrastructure. It is a cloud. Intel tends to use this definition. There's nothing wrong with that definition. It's just not what we're talking about here. And then a third definition that we see occasionally but less commonly is the notion of cloud as this singular, ubiquitous, omnipresent thing where magical things happen. This is a Microsoft definition to the cloud. I send it, and in that sense, it's cloud is being used in a term like you're talking about the cloud, like the internet or the web or heaven, right? Is my thing has gone somewhere, and I don't really care where, and it's come back, and I feel really good about it, right? That's not the definition we're using here either. In this case, the cloud resources are something necessarily a lot more distinct or discrete, like Amazon EC2 or like an engineering services company might be providing a cloud. So that's what we're talking about here. Okay, then in terms of public versus private, once we've set up that definition, public versus private, we really see there being four pertinent toggles or variables in terms of what determines public versus private. One is who owns the resource. The other is who possesses the resource, right? Where is it located? The third is who administers the resource, right? And then administers and maintains over time. And the fourth is who provisions the resource, who decides what's running on it on any given time. If all four of those are somebody else, like Amazon, then it's a public cloud. If all 4 of those are internal to your own organization, then it's a private cloud. And if you start mixing and matching, I own the machine, but it's somewhere else and someone else is maintaining it, then it's some form of a hybrid. Now, is that oversimplified? Yeah, I guess, but we got to get through the damn survey. So we set up some definitions and we go with it. All right, so with way too much setup, the main point of this survey is that most of the usage falls into this concept of private and hybrid clouds. People are looking at clouds. They're looking at a lot of virtualization internally and co-locating a lot of resources necessarily. But the strictly public aspect of cloud has been a small part of HPC. We think it will continue to be a small part of HPC. I will underscore the notion that utility computing is not a new model. I've been fond of saying that it's been around since the 1970s. Someone at HPCC corrected me last week and told me the 60s. Utility computing's been around a long time, and it's never represented more than about 1 or 2% of HPC spending. Cloud might be really goosing this and getting us up to like 3 or 4%. And that would be, double. So, that's awesome, but it's public cloud is not going to be huge. Here are some of the reasons. When we put together this survey on cloud computing, we did a lot of qualitative research first. We did 30 in-depth phone site interviews around cloud before doing the quantitative survey, and as a result, we put together the barriers into 5 convenient categories of barriers. Security is the obvious one. Result quality was an interesting one we hadn't fully appreciated until we started interviewing people, but how do I know that my result is right, and how do I know that it's reproducible, and that I'm getting the same result out of the cloud every time, and the same as the result as I would have gotten internally. Data transfer is another big one. We deal with a lot of people who have hundreds of terabytes data sets. How am I going to get that in and out of the cloud? Which is related to the operational issue of where does this fit into my operations? When does it go to the cloud versus somewhere else? And all of the managerial issues around getting internal buy-in, SLAs. Then there are some meta issues that kind of combine a lot of these things, which is just it's a new workflow, and it's hard to get people over the topic. I mean, you can have all the service level agreements and security agreements that you like, but if I'm bought into the idea that I don't have to have a data center, someone else can do that for me, and I find a nice partner and they have all of the resources and they have all of my data and I just consume it, and then next week they'll go out of business and shut down. Well, now my data's gone and I don't have a data center, and I can hold up a little piece of paper and say, well, I've got a service level agreement, and they say, well, good for you, right? I mean, who am I going to sue? They went out of business. So there's kind of these problems around cloud adoption in HPC. All right, so bringing this back around to OFED, nevertheless, private clouds and hybrid clouds are interesting to a lot of people, and where you need to bring that back in terms of OFED is consider how does this technology fit into a virtualized environment where the main point is to provide timely and reliable access to data. And this is a conversation that I think you can relate back to OFED. In fact, it's not even a very long walk, but it just means you have to talk about it in the context of what the goals of that private or hybrid cloud were, and don't think about it as being all Amazon, because there's just not very much of that. GPU computing, I won't spend nearly as much time talking about, but it is something that is an important trend in HPC right now, especially because China put the number 1, number 3 systems on the top 500 list, plus the Japanese system Tsubame 2 at number 4. All of these traditional barriers around GPU computing have been addressed to some degree by NVIDIA. It's gotten easier to program. It's gotten a little bit faster. They maintain a chip pace of development next to Intel. Intel and AMD that they can keep pace with. But we are seeing, increasing testing, increasing deployments. It's gotten up to about 15% of the market, at least, is trying out accelerators here. Not a lot of huge scale deployments yet, but some. I've changed my tune on accelerators personally over the last 6 months. I used to talk mostly about the barriers. Now I'm starting to think that it's getting to a tipping point because all of the arguments that we hear against GPU computing are very similar to the arguments we heard against clusters. They're hard to program, they're not very efficient, they're bad for most types of applications. You don't have any programs, no ISVs are on board. Heard this song before, right? Eventually they get fast enough, the national labs start buying them and say, it's the fastest, I'm going to buy it, and then I'm going to figure out how to program it. The same thing might be happening here. Interesting dynamics in the middleware market. So, this isn't that relevant because this is looking mostly at commercial middleware. It's stuff that you're spending money on. There's a lot of open source middleware that's free that goes beyond that. So when you say what's the size of the middleware market, it's a tricky question because what do you want me to count? The number of sites, the number of licenses, how much revenue, how important it is to the end user. So it's a squirrely thing to count, but there are a growing number of independent vendors here, most of whom have cloud-dominant stories, and that comes up when you consider what role is OFED going to play here, because you have to find where your voice is in terms of getting a message out in a crowded market. So in terms of the OFED opportunity, and I promise I'm wrapping up here, this is how you might start to view the overall landscape, right? Here's where you are right now, mostly associated with InfiniBand systems in high-performance technical computing, which is a $17 billion market. Beyond that, there's high-performance business computing, which is roughly another $5 billion. We're about to put out a forecast that'll size it more specifically. And then an approximation of, let's call it an $80 billion data center market. We don't publish numbers on that. I'm just, waving my hand at it for now. Thing one is, even if you're there on InfiniBand systems, most people aren't thinking about it that way. So do you want to try to go for conscious usage versus unconscious usage? If that's a goal to try to get more people saying, I'm using OFED. Thing two is you can try to expand to more of the Ethernet-based systems, which comprises the other half of the HPC market and opens up a lot more opportunities. But given that it's RDMA that we're talking about, really you're needing to talk about the heterogeneous and converged interconnect space that go across all of the different types of interconnects that are in this space. Then, how do we pick up high-performance business computing, which is the natural bridge to the data center, because they have a lot of data center-like aspects, but are still primarily concerned with performance for many applications. After that, you can start moving out to the non-HPC data center. Well, so how big is this opportunity? Well, you can move from here, this little corner, to everything else. It's a big difference. But each of these distinct points presents a different challenge, right? And you kind of were discussing all of them at once at this conference. And I think a lot of the discussions about which is most important have to do with which thing are you trying to do first and who your target market is. My recommendation would be, as a group, OFA should figure out the prioritization of target markets and what you're going to do when. Because you don't even necessarily have to do them in order. You could go to the right before you go up or things like that. So in conclusion, there are opportunities for both InfiniBand and for OFED in storage, high-performance business computing in the data center. And then you should consider, I'm not saying this is a slam dunk, consider whether you need to brand OFED as distinct from OFA, as distinct from InfiniBand, right? Is it your goal to get more usage, or is it your goal to get more people to know they're using it? Those are two different things, and maybe the former is sufficient. So that's a discussion for OFA. Most of the cloud deployments are going to be private or hybrid. OFED can absolutely be a cloud optimization tool, but if you go out with a cloud message in a crowded cloud space and you're trying to position against platform and adaptive and Univa and say nothing of IBM and Oracle, your message might get a little lost. So if that's that's important to you, what partners do you need in order to spread that message? Because it's probably not going to be OFA on its own. GPU computing can also be an opportunity in that you have the ability to leverage all of the awareness around GPU. It's just, again, a matter of couching the discussion. There's a lot of awareness right now about the importance of efficiency, keeping the processors working. RDMA and OFED are absolutely relevant points to that discussion. You could build GPU computing into your messaging just to leverage the awareness there, so also represents an opportunity. I think there's a big opportunity to grow OFED. I do question how much of that needs to be a visible versus invisible growth. We're delighted to be associated with OFA. I'm thrilled that I was finally able to attend this conference myself, again, after a couple of years. And I thank you very much for having me. Thank you. Tom, we started a few minutes late, and then I used all my time. Can I take questions or not? Okay. Yes?
On your previous slide about market segmentation, how natural a bridge do you feel, let's say, data warehousing might be?
The question is, how natural a bridge is data warehousing as you move to the right on this slide? Data warehousing is going to be a natural bridge in terms of moving into high-performance business computing to begin with, and then moving out into the enterprise beyond that. Because data warehousing kind of fits into both. It's going to be mostly an enterprise application, but as you get into some of the, as Josh was saying before, big data analytics or things like data mining, fraud detection are going to be bridge sorts of applications. So that's absolutely a valid point. Thank you. Yes, Bill?
How do you recommend we separate OFED from InfiniBand? We started the process in 2006, changing woven fabrics.
Question is, how do I recommend you separate OFED from being InfiniBand only? First of all, I think having the Ethernet people on the agenda here helps, right? I think that's a question of partnerships mostly, from my opinion. If I saw the large Ethernet vendors out there with an OFED story, and it doesn't even have to be Cisco. It could be someone like Arista, Force 10, Emulex, Brocade, Blade Networks, although they're part of IBM now. Get OFED into those presentations. That'd go a long way. Sure. Yes.
How would you characterize the tolerance for the metaphorical fit and finish problems and interoperability issues as you move to the right on your chart? And does that pose a significant barrier to entry as we move to the right?
I'm not sure I understood the metaphor of the finish problem.
So getting the system configured.
Yes. Okay. Thank you. Right. Essentially, your question is how important are the implementation and management issues, administration issues as you move to the right on this chart? They're absolutely foundational. I mean, no one in the right sections of this chart is going to take something that's higher performance and doesn't work sometimes. You absolutely have to have it be viewed as a rock-solid part of an enterprise environment. It has to be considered a standard in some way in order to be adoptable.
So does that contradict the idea that you can pick the order in which we attack these pieces?
Does it contradict that you can pick the order in which you're going to attack these pieces? No, it doesn't contradict that, because you could choose to address the interoperability issues right away, right, and move to the right. But that is going to be a limiting factor if you don't have them fixed. Other questions? Yes, in the back.
Where do you put things like Western Chico's and Veritas? They're utility computing model for gas companies.
Yes.
Where do you lump that, and do you see that as a sign or a trend that could lead to more HPC computing in the cloud?
Right, sure. So the question was around essentially engineering or service provider types of companies. Where do we put them? First of all, it depends on the application. The ones that you mentioned or high-performance technical computing. In terms of where we put the spending, it has to do with what part of the budget it comes out of. If British Petroleum is going to Schlumberger and saying, I'm going to pay you for this as a service, then essentially it goes into utility computing. Although as analysts, we try to be very careful not to double count things, because Schlumberger bought that system to begin with, and it went into somebody's system revenue, and then they resold it as a service, and there's a tendency to count things twice, which in some senses is relevant because people paid for it twice, right? But in some cases is not, because you don't want to overestimate how many systems there are out there. Thank you for the question. Other questions? Excellent. Well, I'll be back again later today moderating a forward-looking panel of what is it that we're going to do about some of the issues that have been raised, not specifically by my presentation, but by others throughout the day. I think it'll be a very lively panel. I'm looking forward to moderating it. Thank you again.